Here's a nice geometry problem. We've got a circle and this square drawn so that two of its vertices lie on the circle, and the other two vertices are connected by a segment that is tangent to the circle. The question is to find the ratio of the circle's area to the square's area. And we won't need too much geometry to do this. We're going to use this construction, this right triangle, where we have a radius of the circle right there, and then right here we have half of one of the square's sides. So here it is all labeled. We're calling the center O. This here is a radius of the circle. If we call the side length of the square x, then this here has to be x over 2. That's because a radius perpendicular to a chord will bisect it. So this is half of the chord, which means it's half the side of the square. Now this segment here has a length of x minus r, because x is the side length of the square, that's this distance here, but then we have to subtract this radius of the circle. That's going to give us that distance. So x minus r. With that, all that's left for us is a little bit of Pythagorean theorem in order to connect the side length of the square, x, to the radius of the circle, r. Applying the Pythagorean theorem tells us that x minus r squared plus x over 2 squared must equal the hypotenuse, r squared. Then just expand the binomial, so x squared minus 2xr plus r squared plus x squared over 4. This, again, equals r squared. Then we'll subtract r squared from both sides. Subtracting r squared from both sides gives us a 0 on the right side. Then we have x squared plus 1/4 x squared, so that's 5/4 x squared, and of course we still have the minus 2xr. Now we can divide both sides of this equation by x. X can't equal 0, it's the side length of a square, so it's certainly non-zero, so we're okay to divide by it. That brings us here. 5/4 x, we divided out a factor of x, so that's just x now, minus 2r, that x got divided out, and this equals 0. So then, add 2r to both sides and multiply by 4/5. Thus, we have x equals 8/5 times r. Now that we've connected the side length of the square to the radius of the circle, we are able to express the ratio of their areas. The area of the circle is just pi r squared. The area of the square is its side length, 8/5 r squared. Squaring 8 over 5r gives us 64 over 25 r squared. We can divide both sides of this ratio by r squared and multiply both sides of the ratio by 25, thus leaving us with 25 pi to 64. That's the ratio of the area of the circle to the area of the square. Let me know in the comments if you have any questions or your own solution, and check the description for links to more interesting math problems. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm a V to the T, my parameter the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me to Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponent